So 8.1.
Wait, I thought it was 6.
No.
You still must be sick, huh?
I heard you say 6.
Oh my god.
6.
No, we're doing chapter 6 now.
Okay. So trig functions are real numbers. A lot of the section is stuff that you already know, but there's going to be some things that we're going to add. Okay, so first, there's going to be like 7 little skills that you need to be able to do in this section. One of them is to use the fact, or I guess I'll just call it sine and cosine values repeat every 2 pi radians. And this is something you know, but we're going to formalize it. So you guys know, for instance, that if I start here, what angle is this? 0. Well, it's not 360, which is 0 radians. Coordinates are 1, 0, right? If I were to go around the whole way, which is 360, that's also the same as 2 pi, right? We still get the same coordinates, which means then that the sine and cos, basically all the trig values are going to be the same at that position. Does that make sense? This works for any angle. So let's say I started at pi over 4. Okay, what are the coordinates at pi over 4? Root 2 over 2, root 2 over 2. Now, if I add 2 pi to that, pi over 4 plus 2 pi, let's see what angle that is now. That's the same as pi over 4 plus, what's 2 pi if I put it over 4? 8 pi over 4. So pi plus 8 pi is 9 pi over 4. So what this means is that if I were to go back to the beginning and go all the way around here, this black angle is 9. Oh, and it's fading away. Okay. That pi over 4, 9 pi over 4, even though they're not the same angle measure, because one's clearly bigger than the other, have the exact same coordinates. Do you guys see that?
But how do you know that that's where 9 pi over 4 is?
Because I just started at pi over 4 and then added 2 pi, so I'm going to land in the same exact spot. Because 2 pi is just a circle, a full circle, right? Does that make sense? So the idea here is that any angle, if I start, let's say, with angle T, and I add 2 pi k, this just means any multiple of 2 pi. So if I start at 30 degrees, or pi over 6, and I add 2 pi, or 4 pi, or 6 pi, or 8 pi, or even subtracted 2 pi, or subtracted 20 pi. All that means is if it's going to spin around a bunch of times but land in the same exact position. Does that make sense? And therefore, the sine value doesn't change. So, and this kind of shows it, the sine of 9 pi over 4 is going to be the y coordinate, which is root 2 over 2, which is the same thing as just the sine of regular pi over 4. Does that make sense? Okay. That works for cosine too. So this represents any angle, t. I could do that for cosine, and that stays true, that the original angle, whether I add 2 pi or any multiple of it, that'll stay the same. Okay? So, real quick, an example illustrating this particular skill. Find 3 angles that have a cosine of negative 1/2. Okay. There are multiple answers here, but probably the easiest thing to do would be to just find the first angle, which would have to be in what quadrant? Quadrant 2. And what angle is this where the x or the cosine is negative 1/2? Does everybody buy that? So 2 pi over 3 is one angle that has a cosine of negative 1/2, right? And since I know from before that if I just added 2 pi, I land in the same spot, I could add 2 pi to this value. What's 2 pi equal? And if I put it over 3? It's 6 pi over 3. You have the answer. Which, if I add 6 pi over 3 to 2 pi over 3, gives me 8 pi over 3. 8 pi over 3 would just be to start where we normally do, go to 2 pi over 3, but then go around an extra circle and end up at the same spot. And if I needed a third angle that has another cosine of negative 1/2, I could just keep adding. This is the key, 6 pi over 3. So what's the next one? 14 pi over 3. So all three of these angles would have the same cosine value. Now, obviously, I picked quadrant 2. Could we have also done quadrant 3 angles? Works the same. Okay, but it didn't say this represents 2 pi. Right? Remember, if we go around an extra circle, we land in the same position. Okay? So these are the answers. Any other questions on the first skill? Yes?
So if angles, is it okay if we just leave it on radian?
Yeah. Well, you could do any mode, really. You could say, well, I know 120, and then just keep adding 360. It's the same thing. Yep. Anything else? Yep.
So you get 2 pi over 3 plus 2 pi, and you have 6 pi over 3, and then you just keep adding.
Yes, so I took 2 pi over 3. I added 2 pi to it, which is identical to 6 pi over 3, to get 8 pi over 3. And I added 2 pi again to get 14 pi over 3. So all these angles, so basically here's 2 pi over 3. I go around another time. This would be 8 pi over 3. If I go around another 2 pi, same position. I don't know why it curved like that, but you get the idea. Same position again. Does that make sense? Okay, so that's skill number 1. If you got skill number 1 down, skill number 2 is easy. It's just evaluating trig functions for quote-unquote larger angles. We'll do 2 quick examples. We've kind of done this already a little bit, so it shouldn't be too big of a deal. Let's start with radians, since that's generally a little easier. Let's say I wanted to find the cosecant of 19 pi over 4. So your thought process should be as follows. First, where is 19 pi over? You don't have to actually draw it, but just figure out what quadrant it's going to be in. Okay? The easiest way to do that is to think in terms of 4. So think about multiples of 4. Okay? We start with 4. What's the next multiple of 4? 8. Keep adding 4. 12, 16, 20, 24. Which multiple of 4 is 19 really close to?
10.
It's almost 20 pi over 4. Almost, not quite. It's a little less, right?
5.
What's 20 pi over 4? 5 pi, and we should be able to do that no problem, right? So if I start here, from here to here is 1 pi. If I go all the way around, that's 2 pi. You guys with me? This would be 3. This would be 4. 5 would land right back here, but since I'm not all the way to 20 pi over 4, what do? You just stop a little before then. So what quadrant is this? Second quadrant. And the nice thing about radians is if it's a pi over 4, we know what x and y are, right? What's x and y? root 2 over 2, root 2 over 2, but in quadrant 2, x is negative. All right, so that's the first thing we do. First, we figure out what quadrant we're in. Then you write out the coordinates for that point. And now you evaluate using the definitions. Cosecant means reciprocal of what? Of sine or y, right? Which is the same thing. So I'm going to look at my y coordinate. Reciprocal of root 2 over 2 means to do 2 over root 2, which if you've done enough, you know becomes just root 2. And if you don't see that, multiply by root 2 top and bottom. You get 2 root 2 over 2. 2's cancel. You get root 2. Does that make sense? Yes?
Will there ever be anything weird? Because, like, so you know of something over 4 that has to do with, like, 45 degrees and stuff for the radian. Will there ever be anything weird, like something pi over 7 or...
No 7s.
Okay,
Nothing
so
like
it's
that.
like-
Next unit, we'll deal with 12s and things like that, but you're always, if it's in radians, you're always going to have 3, 4, 6 as the, or maybe just pi. Or 2, pi over 2, 3 pi over 2, stuff like that. Okay? Let's do one in degrees. Let's say cosine of 600 degrees. So hopefully it's kind of jogging your memory a little bit, getting that trig back out. Is it third? Let's see. All the way around is 360. What's next?
90.
This is 540, right? So if I go an extra 60 degrees, there's where I am. You're right, third quadrant. And this is the reference angle right here, 60, right? That's the family of angles I want to think about. What are the coordinates for 60? 1/2, root 3 over 2, and now we adjust. In quadrant 3, everything is negative, so cosine is just negative 1/2. And it's that easy. You do have to slow it down a little bit until you get back on the swing of things, but that's the second skill. Evaluating bigger angles. You guys good with that? Yes. 7. Well, most of them are review. Like, so far we haven't done anything that's weird or new. Okay?
Weird.
I don't think it's weird.
Go over our test.
Maybe if we have time.
How were they?
You guys did okay. All right, skill number 3 is the Pythagorean identities, or using them. You already know one of the Pythagorean identities. The big one that we kept talking about over and over. You guys remember it? Cosine squared. I'm going to use t since the book likes to use t in this unit. Cosine squared t plus sine squared t equals what? 1. Don't ever forget that, right? So this is one that we already know. And now to get the other two that you have to memorize, and honestly, I forget them sometimes too, but I remember the trick, okay? If I divide everything by cosine squared, you get a new identity. What's cosine squared divided by cosine squared? 1. Good. What's sine squared over cosine squared? Tangent squared. Good. And what's 1 over cosine squared?
We already know that.
Secant squared. Good. So this is identity number 2. You've actually proved, it was actually on a test, I think, or a quiz. You proved this already, but now you're gonna be expected to memorize this, or at least be able to figure it out real quick. Okay? Do you guys see how we got from here to here? Guess what the other trick is?
Divide by.
Go back to the original big one and divide by sine squared. So now what's cosine squared divided by sine squared? Cotangent squared, very good. Plus, what's sine squared over sine squared? 1. And then 1 divided by sine squared is cosecant squared. Good. So these are the three Pythagorean identities. Okay? I'm not going to do... Maybe not yet. That's it. Pythagorean identities. Any questions on how we got all three of them?
That's it for today.
No, for this section. Okay? All right. Fourth skill. Since at least I think I did a good job of emphasizing this whole triangle thing, you should not have any trouble with this either. So, the fourth skill is given any trig value. Find the others. In the last unit, usually they told you a sine or a cosine. Now you can be expected to get a secant, a cotangent, or anything really. So here's an example. If secant of an angle t equals, let's say, negative 5 over 4, and let's say t is between pi and 3 pi over 2, let's just find cosine t, bless you, and tangent t. Okay. Do you guys remember how I said, maybe you don't, but I'll remind you, anytime they tell you a trig value, that you could always draw a triangle and label it, depending on what they've given you? So if I put angle t here, they told me that secant is negative 5 over 4. Now I have to sneeze, but it's not coming out. It went away. Okay. Secant is the reciprocal of what? Cosine, right? So that means that the cosine, which they're asking us for, should be just the reciprocal of that, right? So negative 4/5. And if I know the cosine, what two parts can I label here? The hypotenuse and the adjacent. Which one of the adjacent would be? So 4. Hypotenuse is 5. Again, I don't use any negatives until the end.
So 3.
And this is a nice one because it's a triple if you don't remember him. But 3, 4, 5, done. So if I find tangent, tangent is opposite over adjacent, so we get 3/4. And then I had double check. This information told me that the angle was in what quadrant here? Between pi and 3 pi over 2 means we're over here somewhere. In the third quadrant, x and y are negative, so tangent, which is y over x, is positive, so we're okay. You guys see how I did that? Okay. Any questions? Okay, on to skill number 5, cruising through this. Use a trig substitution to rationalize a square root. This is a skill that you will use more frequently in calculus, and you'll have to be able to figure out which trig substitution to use. Okay, I'll let your calculus teachers kind of deal with having you tell between which one to use or not. Right now, it's actually really easy for you guys. They will tell you what to use, and all you have to do is plug it in and figure it out. It's that easy. So, for example, they'll say, if we have u over the square root of u squared minus 3, let's say, and they tell you to do the substitution u equals root 3 secant theta. All you have to do is take what they tell you and plug it in. And it's just your job to simplify it. Okay? So in the numerator, what do I get? Root 3 secant theta In the denominator, if I plug in u squared, if I square the root 3, it becomes 3. Square secant, secant squared, and then the minus 3 is still there. Holding.
So wait, theta?
All I've done is literally,
That's it?
I've just plugged in u. It's like if they told me, if u equals 5, figure it out. So you do 5, and then you do 5 squared and subtract 3. All I'm doing here is plugging in root 3 secant theta for u, right? And then I plug in, do you guys see that if I square u, if I square that and I square this side, the root 3 becomes 3, and then secant times secant is secant squared, so that's how I got the u squared here to become this. Okay? All right, Justin, what next?
Then have to rationalize by multiplying the top and bottom by root 3 secant squared theta minus 3.
That's actually you can do it that way. There's something that you can do first that'll make it a little easier. What's in common down here?
3. All I can take out.
So let's take out a 3 in there. If I take out a 3, what's left?
Secant squared minus 1.
Secant squared theta minus 1.
Which is
And now here's the nice part about all these substitutions they're going to give you. When you get to this point, this always equals something that we've been dealing with, like one of the identities. If you don't know which one it is, here's the new ones. Can you guys see them?
it's not,
Yep. Do you guys see that if you subtract 1, you get tangent squared? Tangent squared equals secant squared minus 1. That's exactly what we have here. Okay? So the next step is to rewrite it as just root 3 tangent squared. Okay? And now we square root everything. The square root of 3 is just square root of 3. The square root of tangent squared is tangent. So now what happens? The square root of 3's cancel out. And then now if you don't see it, probably the easiest way to do this is to write everything with cosines and sines and simplify it. So what's secant? 1 over cosine. Tangent is the same as sine over cosine, but we're going to multiply by its reciprocal. Very good. Cosine over sine. So tangent is sine over cosine. And then we're going to do the reciprocal since we're going to multiply instead of divide. What happens next? Which means that the cosines cancel. What's 1 divided by sine? Cosecant.
That was fascinating.
It's weird. But here's what you need to know, okay? This will be given to you. This will be given to you. Your job is just to plug everything in and clean it up. Yes. You don't have to figure out what to plug in. It's pretty easy. Okay?
You just have to remember, like,
Yep. Almost done, guys. Sixth thing, identities. They're not going to go away. So we'll do a quick one.
How many sevens?
Yeah. So all the stuff that we did with identities before break, you still got to know how to do. The only thing that's different is that now you have more things that you can use at your disposal. Mainly these guys, or any variation of these three. Does that make sense? So instead of just this one, cosine squared plus sine squared equals 1, or 1 minus cosine squared, or whatever, you can use these two or any variation of these two. So here's an example. Cosecant t plus cosecant t cotangent squared t all over secant squared t minus tangent squared t. We want to prove that that equals cosecant cubed t.
Wait, just a second. Squared or cubed? It's cubed.
This is cubed, yep. These are squares.
Oh.
Now, yes?
Would you want to change anything in the sine and cosine first? Would you have us first try to figure out the identities?
Yes or yes.
Wait,
Either way will work.
Okay.
If you change everything in sines and cosines, then all you're going to do is do it like we did last unit.
It's in the bottom.
Okay. Say that again. The bottom equals 1. Let's check that out.
Oh,
Oh, yeah.
right.
If you have secant squared and you subtract tangent squared, that's the same as just 1. You guys see that?
Oh, yeah.
Well, that's nice.
Thanks.
So can we do anything up here before we change the sines and cosines? Let's do that. Factor out the cosecant. And what's left?
It's 1 plus oh.
1 plus cotangent squared. Remember, this was 1. And actually, don't we have a new identity for this? What's 1 plus cotangent squared? That's cosecant squared. Well, what's cosecant times cosecant squared? Cosecant cubed. This is very hard, yeah. Now, two or three steps here. If you forgot the new identities, you can do it the old way. You'll just have a couple more steps. Okay? Any questions on that? All right, last thing here. What did I call this? Ah, yes. Even and odd stuff. Let's just start with this. Let's say I have an angle. We'll call it theta. Here it is. What are the coordinates? Not what are they, but positives and negatives up here in the first quadrant. Plus, plus. Now on the same graph, sorry. How do I graph negative theta? Where would that go? Just in the fourth quadrant, opposite it, right? What do the coordinates look like here? Plus, minus. Can you guys remember this picture? If you remember this picture, then this is going to be very easy. Cosine theta is positive, right? What about cosine of negative theta? If they're both the same coordinates, then we can say cosine theta is actually equal to cosine of negative theta. Do you guys understand that? Let's do sine. Sine theta would be what? Up here. Positive. But if I go in the fourth quadrant, so it doesn't equal itself, but it equals the whoop, I just wrote it backwards. Sorry. Sine theta does not equal sine negative theta, but I can fix this by just putting a negative in front of the first one. Okay? These two are called opposite angle identities. And all you need to know then is that the cosine of an opposite angle is just equal to the cosine of its regular angle. The sine of a negative angle is equal to the opposite of the sine of the original angle. Okay? So what it looks like is this. Okay? If I tell you that the sine of t is equal to 0.89, and I ask you what's sine of negative t, you could just think of this picture or think of these rules right here. So if the sine is positive, when I do the negative angle, what happens to the sine? It switches from positive to negative. So the answer here, that sine of negative t, would be what? Negative 0.89.
Is that really it?
Yeah.
What's the,
These are actually really easy. What's that?
what's the cosine?
Well, let's do a cosine example.
What's the catch?
The cosine of t, let's say the cosine of t is negative 1/5, and I want you to find the cosine of negative t. Think of the picture or think of the rule. If the cosine is negative, so you could think of it like this. If the cosine is negative, then theta's got to be over here somewhere, right? Well, where's negative theta? Just over here, right? What do you notice about these coordinates? These x-coordinates will be the same. So the cosine of t is negative 1/5 means that the cosine of negative t is also negative 1/5.
So for the sine, it does change.
Yes.
Opposite, like. So sine for the cosine.
Sine, let's do it this way. Sine switches. Can you guys remember that? Sine, S for sine, S for switches. Sine switches. Cosine.
Consistent.
I like it. Consistent.
Yeah. Yes.
You guys good?
That's really cool, actually.
Sine switches, cosine consistent. All right.